Welcome everyone to another video of Tutoring with Liah. Today I'm going to be talking about the oxidation number rules. Rule number 1. The oxidation number of an element in its elementary state is 0. This means that when an element is by itself and not mixed with another element, then its oxidation number will be 0. For example, if you have iron by itself, the oxidation number for this will be 0. If you have O2, oxygen gas, because oxygen is by itself and there is no other element mixed with it, the oxidation number for each of these oxygens will be 0. For example, if you have another element, if you had Cl2, the same case applies where you just have chlorine here and no other element, so the oxidation number will be 0, and so on. Rule number 2. Oxidation number of a cation or anion is the charge shown for the ion. So this means that if they tell you the charge, if they tell you that magnesium has a +2 charge, this would be a cation. We know that cations have a positive charge and anions have a negative charge. Then you know that for this ion, the oxidation number will be 2, +2. If they gave you nitrogen and they said that it had a -3 charge, well, we know that negatively charged ions are called anions. And so the oxidation number for this nitrogen would be -3 because they told you. So rule number 2 is just saying that if they tell you the charge of something, then that is going to be the oxidation number. Rule number 3. Almost all halides have oxidation number as -1. Group 1A has +1 oxidation number, and group 2A has oxidation number +2. Okay, so we know that the halides in group 7 are located right here. So the elements in this group will have a -1 oxidation number. Moving on, group 1A has +1 oxidation number, so we know that this is going to be group 1, and we'll have a +1 oxidation number there. And then for group 2, right here in purple, this one will have the oxidation number of 2. So the elements in group 2 will have a +2 for the oxidation number. Rule number 4. Sum of oxidation numbers is the charge of the species. If neutral, oxidation number is 0. If the species is an ion, then oxidation numbers must add up to result in that charge. If, for example, we were given NO3-, this minus here tells us that the entire compound has a -1 charge. So if we follow our rules, then we know that oxygen here is going to have a -2 charge. So each oxygen has a -2 charge. There are 3 oxygens, so the total charge coming from oxygen will be -6, which is found by multiplying 3 times -2. Now in the end we want a -1 charge, because that's going to be the total charge for the compound. And so we know that we already have a -6 involved. So what -6 is going to give us -1? Well, the answer is going to be 5, because 5 minus 6 is going to be equal to -1. So we know that 5, this is going to be the oxidation number for the nitrogen. So here we can see that because they gave us a charge of -1, then our oxidation numbers for the elements involved, in this case nitrogen and oxygen, those oxidation numbers need to add up to -1. Now what if we had a neutral compound here? What would be the oxidation number of chlorine, and what would be the oxidation number of copper? So in this case, following this rule number 4, if the species is neutral, right, so that means it has no charge up here, okay, then the oxidation numbers here need to equal 0. So following our rules that we already know, so following our oxidation number rules, we know that chlorine will have an oxidation number of -1 because it is a halide, and because there are 2 chlorines, then the total charge coming from chlorine is going to be -2. That's just 2 times -1. Now, in the end, we want everything to have a neutral charge. So everything needs to add up to 0. We already know that there is a negative 2 involved. So now we ask ourselves, what minus 2 is going to give us 0? Well, we know that 2 minus 2 will give us 0. So positive 2, then, will be the oxidation number for copper. So in the end, we can see that copper will have a positive 2 charge for its oxidation number, and chlorine will have a negative 1 for its oxidation number. So each chlorine has a negative 1 charge. Now moving on to rules 5 and 6, these are just going to be your references here. They just tell you the oxidation numbers for certain elements here. So fluorine, they tell you here, is going to have a negative 1 charge or oxidation number. Oxygen is usually going to have a negative 2 oxidation number. Hydrogen is going to be positive 1 oxidation number, but it will be negative 1 if you have it paired with sodium, and it will be also a negative 1 if you have it paired with lithium and aluminum. For rule number 6, halogens besides fluorine are usually negative 1, but are positive 1 when paired with oxygen or fluorine. If for some reason you had an oxygen paired with 2 chlorines, so because this halogen chlorine is paired with oxygen, then the chlorine must take on a positive 1 oxidation number for each of its chlorines, and so the total oxidation number coming from chlorine will be 2 times positive 1, which is 2, and then we know that from the rule above, number 5, that oxygen usually has a negative 2 charge. And so this makes sense because when we add up these numbers, right, the final oxidation numbers, we have a positive 2 and a negative 2, which we know 2 minus 2 is 0, so this entire compound has a neutral charge, which we found here. Thank you so much for watching this video. I really hope you found it helpful. If you did, please consider subscribing and leaving a comment down below. I'll see you next time.